This is going to be a video on how to load the imagery and the shape files into QGIS for the lander strike slip mapping assignment. So first we're going to download all of the files from the course website and store them in a known location on your computer. We'll begin by adding the imagery and the mapping boundary. So we can find it in our browser, drag them down. That's the mapping boundary. And here is the imagery. You'll always want to make sure that the mapping boundary is on top of the imagery before mapping, so you don't map more than you need to for the assignment. And if you like to change the symbology or the color of the mapping boundary, you can do that too. And this aerial imagery was acquired in 1992 prior to the 2002 rupture. We can look at the information about this data by double-clicking on it. Going to the Information tab, here's all of the information about the data. And if we scroll down to pixel size right here, we see 7, and that is the resolution. So 7 meaning it's 7 meters per pixel. Now we'll add in the geologic map unit shapefile. And it'll be labeled Landers Geologic Map Units. We can click that and drag it down. If it's loaded correctly, you'll see a sample polygon that I've made right here with the style file. If not, we can load the style the same way that we've done in the past by double clicking and going to symbology, down to style, load the style. But these are going to be all the units we're mapping with. The explanation of these features is found on the reference document posted on the website, but it was modified from a Ramus et al. Surficial geologic map. And these symbols, specifically these values, are what we're going to input into the feature attribute table to make sure the polygons plot correctly, and they're case sensitive, so it's important that we use the same capitalization and nomenclature listed here. Once we have these loaded correctly, we can go ahead and add the GIR and the fault confidence ranking shapefile. And you can double check the style is loaded onto this as well. We changed the GIR shapefile slightly per your guys' suggestions. So all of the rankings have been assigned a respective color. So features with a ranking of 4 are going to be displayed as red, meaning they have the most indication of faulting. Features with a ranking of 3 are orange, 2 is yellow, and 1 is blue. So now that we have all of the files loaded into our layers correctly, we can start looking at the imagery as a whole. We can see it's a larger alluvial fan complex. It is displayed in black and white, but we can still pick out some tonal differences in the surficial deposits. We zoom in right here. You can start to get a sense of the difference in topography, erosion. You can sort of see some of the vegetation within some of these drainages. And it's important to study these differences of each surface because these are going to be the factors that help you determine the relative age of the units for the geologic mapping. And so the first thing we'll want to do in this assignment is create a geologic map for the whole area. To do that, we're going to click on our layer, toggle on the editing. And before we do anything to save us some problems later, we're going to change the snapping tolerance of our layer. So to do that, we're going to go up to settings, options. On the left side, digitizing, and there'll be this panel that says snapping. We want to enable snapping by default, hit vertex, and then I just have it changed to 25 pixels just to make sure that it will catch any vertex. Hit OK. But we'll also want to do it as the project for a whole. So we'll go to project, snapping options, this little magnet, enable snapping. I like to have it on just the active layer, vertex, 12 should be fine. You can enable the topo and the snapping on intersection, and you'll be good to go. And this is just so that when we start to map polygons right next to each other, we don't have any little gaps in between them that they aren't matching up correctly, and it just looks a lot cleaner. So to begin mapping, I'll use this southwest corner as an example. We'll toggle on the editing. I'm going to delete this just for now. And let's say I want to map this darkest feature in the corner extent of the mapping polygon. So we'll go up to add polygon feature. I'll zoom in a little bit more, and you're going to start to click out the extent of where you'd like the unit to be mapped. I'm going to do it just a little bit rough and dirty to save us some time. And then when you right click, it'll bring you to the feature attribute table. You won't have to worry about the ID, but the unit is where we're gonna type in the symbology to assign a map unit for that polygon. And again, it will be case sensitive. You can either refer to the symbols listed in the symbology of the shapefile, or you can look at the reference document on the website. But I'll map this as bedrock. So I'll do capital B, lowercase r, hit OK. If it mapped correctly, it'll have the symbol and also like a red tan color according to the symbology. And let's say I didn't like some of how I mapped it, the extent of it. So you can change the polygon after the fact by going to the vertex tool. And to do that, we're going to go up to the toolbar, select features, select the polygon that you'd like to edit. And you'll see on these red X's everywhere that I've clicked out to make the polygon. We'll go to vertex tool. It's located right next to the add polygon feature. Let's say if I zoom in right here, I didn't exactly make this as clean as it could have been. It kind of goes past the mapping extent. It doesn't go all the way over there. So if you hover over one of the vertexes, it'll have a red circle and you can click it and you'll see this kind of faint red line that shows you where you're going to change the extent of the polygon. So I'll just click it and drag it over a little bit. It'll match up with the extent of the mapping polygon a bit cleaner. Once you're satisfied with what you're changing, you can go back to the select feature, click away from it, and that'll lock the polygon in place. Now I can add another feature. Let's say I want to map this darker superficial deposit coming through the two bedrock units. I'll start clicking out. I won't do the full extent of this unit just so it saves us some time. And once you get to the boundary of another polygon that you've already mapped, you'll see that when you start to hover over a previous vertex, our snapping tool that we've added before will highlight a pink square where a previous vertex was. So you'll want to click along everywhere you see one of those squares to make sure that they're matching up correctly along each boundary. And I will list this as a young alluvial fan deposit. And so again, case sensitive, so we'll do capital Q, lowercase y, a, hit OK. And if it plots correctly, it'll look like this. I'm going to pause it just to do a little bit more mapping to give you guys a sense of what it'll look like. So here I've done a bit more geologic mapping to kind of fill out this area. You'll notice that some polygons have a bit more detail than others, so it'll be up to you to decide the level of detail you want to put into it to suss out some of the drainages or not. Like you'll see here for this QIA, like Ramon mentioned in his lecture, that it's intermediate alluvial fan on top of the tertiary unit. So it'll be up to you to determine how you would like to distinguish that or assign a map unit to it. But I did want to show right here where I decided to add another bedrock polygon, but it is right next to an existing bedrock. And so it doesn't look as great when there's two right next to each other and there's a line separating them, even though it is the same unit. So a way to merge these polygons so it looks a bit cleaner is to go up to select features, and you can select both of them. Make sure that no other ones are selected by it. And you can go to the edit at the very top and click merge selected features. It'll show you the attribute table of the two previous units, whatever nomenclature you picked. And then when it's merged, it'll show you that it'll still be bedrock. When you hit OK, it'll all be one single polygon now. And so you'll want to do the geologic mapping for the entire area before you move on to making any interpretations or anything about the geomorphic mapping and their relationship to faulting. But now we've finished the geologic mapping, we can begin doing the GIR feature point indicators. So we'll save our layer edits and turn off the editing for the map units and begin editing with the GIR feature. And it'll be probably abundantly more clear where some of these features are after you finish the geologic mapping. So that's important that you do that first. But I noticed here, and you can toggle this on and off to see it a bit more clearly, that there's some disruption in the surface fan units right here and a bit of lineation. And you can see that too with it. It doesn't match up quite cleanly or the natural progression of a fan. So I will want to put a GIR feature right here. Let's say I want this to be a surface unit offset. So toggle on the editing, add a point feature, and I'll put it right here. We already know that this is a strike slip system, and we can go back to the GIR table to look for the symbology. But again, it is case sensitive, so we want everything to be all capitalized. Put SS and I'll put surface unit offset. Hit OK. And it should display as the yellow marker. And we've added again to the style file for the updated GIR, the label next to it, so it's easier for you guys to tell what dot is what dot. Let's say I wanted to add a morphologic element over here as well. For one of my modifiers, I could put ME. It'll plot as the gray circle with an ME, so it knows what modifier you mapped. You'll want to do this for the whole area as well before you start drawing any fault traces. But once you have finished all of the GIR point features and the geologic mapping, we can use the evidence we've gained up to that point to draw a simple fault trace. And to do that, we can go ahead and save and toggle off. We're going to create a new shapefile layer for just a simple fault trace. I can just call it simple fault. Make a line, save it to the same folder that I have the rest of my files in. Click OK. I'd like it to be a simple red line. And we can draw where we think the fault will be. So we could toggle editing, add a line feature. So I think that one of the fault traces cuts across like this. Once you're confident with the trace, you can right click, hit OK. It'll be there for you. And you'll do that for every fault location that you have in the area. You can do the same thing and edit the vertex if you'd like to change the location of it. If I wanted it to be a bit closer to where that surface unit offset is, that's okay. But you'll want to have the fault trace for the whole map, and then we can begin segmenting the fault into 1 kilometer segments to assign a fault confidence ranking. You can do it one of 2 ways, like we mentioned before. You can either just measure it out with the measure tool, and let's say it's right there, and look for a marker where the 1 kilometer segment ends, or you could do it another way and add a shapefile for the segment marker. And this might help you keep track of where the segment starts and ends when you have to retrace it with the fault confidence ranking shapefile. Let's say like that was where one of the segments ended. So everything from that end of the trace to this end of the trace will be considered one segment, and all of the GIR features that you've mapped will be counted into that segment for the fault confidence ranking. And so it'll be more of a qualitative assessment by you guys. So you can look at the quantity and the ranking of the features within that segment to assign a fault confidence ranking score. And if the traces, sometimes they're going to be shorter, if they're less than 1 kilometer, you can just leave it as is and just count it within that trace. And it helps me to map all of the segments before, so then I'll know against each other, against what segment, what to rank it as. Because if I have just this one segment, there's only 2 GIR features for it, but there's another segment somewhere up in this mapping area that has more segments of a higher ranking, I'm not going to want to place this one as strong as maybe the segment up there. But once you've segmented everything and decided on a ranking for each segment, we can now implement the fault confidence ranking shapefile. So we can edit that off, begin this edit, and you're just pretty much going to trace directly over the simple fault trace. You'll right click, it'll bring you to the feature attribute table. And this is where you're going to put in if it's a primary or secondary fault, as well as the quality or the fault ranking for it. You can refer back to the GIR presentation, but we're also going to discuss more about tips and tricks that help you determine whether or not the trace is going to be primary or secondary. For the sake of the example, I'm going to say it's primary and it's case sensitive again, so we'll want to do a capital P. And let's say I want this to be distinct, so a ranking of 3. You'll map it, you'll know if it's mapped correctly, you can toggle off the simple fault and it will be right here. You'll do that for the rest of the segments and then you'll be done. After you've finished assigning all of them, you can then export all of your files, make sure you have everything saved, the toggles off, so you're not adding any more edits past that point. And you can refer to Chelsea's video on how to save and export your files as assignment to be turned in.